Happy morning, children. Today session is Unit 7 from your 12th standard physics subject, Wave Optics. The last topic, let me continue. The condition for constructive interference for reflected ray is. The condition for constructive interference for reflected ray is 2 mu d plus lambda divided by 2 is equal to n lambda, or 2 mu d is equal to 2n minus 1 into lambda by 2. So this is the formula for the interference in thin film. Interference in thin film for the reflected light. Constructive interference for reflected ray is 2 mu d plus lambda by 2 is equal to n lambda, or 2 mu d is equal to 2n minus 1 lambda divided by 2. Then the next important point is the reflected light for the destructive interference. So the additional path difference lambda by 2 is due to the phase change of pi in rarer to denser reflection taking place at A. The condition for destructive interference for reflected ray is 2 mu d plus lambda by 2 is equal to 2n minus 1, 2n plus 1 lambda by 2, or 2 mu d is equal to n lambda. So this is the formula for the destructive interference for reflected ray. So this is very important formula. These two formulas are very important formula for your objective type question as well as 2-mark problem question. The next topic is diffraction. What is mean by diffraction? So this is the definition of diffraction. Diffraction is the bending of waves around sharp edge into the geometrical shadow region. Once again repeat, diffraction is bending of waves. Here this is the bending of waves. Bending of waves around sharp edges into the geometrically shadowed region. The next topic is Fresnel and Fraunhofer diffraction. Fresnel and Fraunhofer diffraction. Based on the type of wavefront which undergoes diffraction, it could be classified as Fresnel and Fraunhofer diffraction. The difference between Fresnel and Fraunhofer diffraction are, this tabulation is very important tabulation. This is very important 2-mark question, children. Please listen carefully. What is the difference between the Fresnel and Fraunhofer diffractions? For the Fresnel diffraction, first point is spherical or cylindrical wavefront undergoes diffraction. So diffraction shape is spherical or cylindrical wavefront. For the Fraunhofer diffraction, plane wavefront undergoes diffraction. So the shape of the wavefront is plane. Plane wavefront undergoes diffraction. Second point for the Fresnel diffraction, light wave is from a source at finite distance. So listen carefully. Light wave is from a source at finite distance. For the Fraunhofer diffraction, light waves is from a source at infinity. Light wave is from a source at infinity. Then third point is convex lenses need not be used for laboratory conditions. Here for the Fraunhofer diffraction, convex lenses are to be used in the laboratory conditions. Then the fourth point is Fresnel diffraction difficult to observe and analyze. For the Fraunhofer diffraction, easy to observe and analyze. This is the diagram for the Fresnel diffraction. This is the diagram for the Fraunhofer diffraction. So these 5 points are very important for your objective type question as well as the 2-mark question. Please note it down. This is the question for difference between Fresnel and Fraunhofer diffraction. Then the next topic is diffraction in single slit. Diffraction in single slit. This is very important 5-mark question, children. Please note it down. Diffraction in single slit. Diffraction in single slit. Listen carefully. Let a parallel beam of light. This is a parallel beam of light. Plane wave front. Fall normally on a single slit. This is a single slit. AB. Of width as shown in this figure. The diffracted beam falls on the screen kept at a distance capital D here, capital D, from the slit. The center of slit is, this is the center of slit is C. A straight line through C, this is the straight line through C perpendicular to the plane of the slit. This is the slit. Plane of slit meets the center of the screen at O. Here this is the point O. Consider any point P on the screen. This is the point P on the screen. All the light reaching the point is P from different points on the slit. Here different points on the slit make an angle theta with the normal CO, C to O. The next, all the light waves coming from the different points on the slit interfere at point P and other points on the screen to give the resultant intensities. The point P is in the geometrically shadowed region up to which the central maximum is spread due to the diffraction as shown in this figure. We need to give the condition for the point P to be of various minima. The basic idea is to divide the slit into even number of smaller parts, then add their contribution at P with the proper path difference to show that destructive interference. Destructive means dark fringes formed on the screen. So takes place at that point to make it minimum. So minimum means destructive interference. Maximum means constructive interference. Constructive interference means otherwise called bright fringes formed on the screen. So to explain maximum, the slit is divided into odd number of parts. So destructive interference, it is formed in the odd number parts. The same time constructive interference, that means bright fringes formed in the even number parts, even number of parts. The next important point is, this is very important point, condition for P to be first minimum. Minimum means destructive interference. Destructive means dark fringes formed on the screen. Let us divide the slit AB, this is AB, into two half, AC and CB. AC and CB. Now the width of each part is A by 2 here. This is A by 2. From A to C, it is represent A by 2. The another one part from C to B, it is also represent A by 2. So, two of parts are divided from the single slit. So, we have different points on the slit which are separated by the same width A by 2 called as corresponding points. Please note it down, children. This point is called as a corresponding point. Which point? Which are separated by the same width A by 2 called as corresponding point. This is shown in this figure. The light waves from different corresponding points meet at a point P and interfere destructively. Destructively means dark fringes to make it a minimum, the path difference del between the waves from these corresponding points is del is equal to a by 2 sin theta. So from the diagram, del is equal to a by 2 sin theta. Here, sin theta is, what is the formula for the sin theta? Sin theta is equal to opposite side by hypotenuse. So here hypotenuse part is a by 2. Opposite side is del. Here this Bn is the opposite side. Bn, opposite side is represent del. That means path difference. Then the hypotenuse part is a by 2. So sin theta is equal to opposite side by hypotenuse means opposite side del divided by a by 2. Now del is equal to a by 2 sin theta. The condition for P to be first minimum is a by 2 sin theta is equal to lambda by 2. So a sin theta is equal to lambda because 2 cancel to each other. A sin theta is equal to lambda. The next second condition is condition for P to be second minimum. Let us divide the slit AB into 4 equal parts. Now width of the each part is a by 4. We have several, so we have to segregate in a 4 different parts of the slit. One part is a by 4. So a by 4 means that is a one part of the slit. Now we have several corresponding points on the slit which are separated by the same width a by 4. The path difference del between the wave from these corresponding points is del is equal to a by 4 sin theta because sin theta is equal to opposite side by hypotenuse. Opposite side is del, hypotenuse part is a by 4. So here in the step we get del is equal to a by 4 sin theta. The condition for P to be second minimum is a by 4 sin theta is equal to lambda divided by 2. Then a sin theta is equal to 2 lambda. A sin theta is equal to 2 lambda for the each part of a by 4 in the slit. So a sin theta is equal to 2 lambda. The next condition for P to be third minimum. So the same wave, the slit is divided into 6 equal parts to be explained. The third minimum. The condition for P to be third minimum is a by 6 sin theta is equal to lambda by 2. So a sin theta is equal to a by 6 sin theta is equal to lambda by 2. So a sin theta is equal to 3 lambda. A sin theta is equal to 3 lambda. Then condition for P to be nth minimum. Dividing the slit into 2n number of even number of equal parts makes the light produced by one of the corresponding points to be cancelled by its counterpart. Thus the condition for nth minimum is a by 2n sin theta is equal to lambda by 2. This condition is a by 2n sin theta is equal to lambda by 2. So a sin theta is equal to n lambda. A sin theta is equal to n lambda. The next, when n is equal to 1, 2, 3 is order of diffraction minimum. N is equal to 1, 2, 3 up to nth term is order to diffraction minimum. Now, second condition is condition for maxima. Condition for maxima. For point of maxima, the slit is to be divided into odd number of equal parts so that one part remains uncancelled, making the point P appear bright. The condition for first minimum is a by 3 sin theta because this is odd number. So a by 3 sin theta is equal to lambda by 2. So a sin theta is equal to 3 lambda by 2. The condition for second maximum is a by 5. This is odd number means a by 5 sin theta is equal to lambda by 2. So a sin theta is equal to 5 lambda by 2. The condition for third minimum is a by 7 sin theta is equal to lambda by 2 or a sin theta is equal to 7 lambda divided by 2. In the same way, condition for nth maximum is, in the same way, condition for nth maximum is a sin theta is equal to 2n plus 1 lambda by 2 nth maximum. So where n is equal to 0, 1, 2, 3 is order for diffraction maximum. The central maximum is called 0th order maximum. Central maximum is called, this center point is called 0th order maximum. The points of the maximum intensity lie nearly midway between the successive maximum. So thank you very much, children. This is very important detailed question answer. Diffraction in single slit. Diffraction in single slit. So this is very important question. The next topic is discussion of first minimum. Discussion on first minimum. Then Fresnel distance. Fresnel distance. Let me continue in the next video. This is also very important topic. Thank you very much, children.